With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let's begin with the question. And in the question, it says that in an experiment with Foucault apparatus and the various distances used are as follows. Here it says that distance between the rotating and the fixed mirror is 16 meter. Distance between the lens and the mirror is 6 meter. Distance between the source and the lens is 2. And when mirror is rotated at a speed of 356 revolution per second, the image is shifted by 0.7 millimeter, or we can say 7 into 10 raised to the power meter. So let's begin with the problem. First, we will understand what happens in the Foucault experiment. So let's draw the diagram first. So here we use one mirror, that is here, it is fixed mirror, and it is partially reflecting and partially refracting. In between them, we have placed a lens right here. Then we have another mirror which is at here, and here we have a spherical mirror. So to draw the spherical mirror, what we do here, just cut it like this. So this is the mirror, and it is the curved mirror right here. So this is curved mirror. This plane mirror is partially reflecting, partially refracting, and this is the rotating mirror. So this is what we have. So what we do in this experiment, we place the source right here, and the light from the source will comes out like this and falls on this rotating mirror, and we intentionally place this mirror so that the light falls on this point, which is the center of curvature of this curved mirror. So when light falls on this point, the light goes towards this mirror and retrace that path, again reaches to this point. This time we use, because it is partially reflecting and partially refracting, so here from this point it reaches the source, it reaches the observer where we want to observe. Okay, so this is how light traces its path. Now, by using this experiment, the Foucault was able to give the formula, and that formula was C is equal to 4 r square omega into A, and this is divided by S into R plus B. Now we will discuss what are those points. Now in the first line right here, this says that the distance between the fixed mirror and the rotating mirror is 16 meter. So they are talking about this mirror and this mirror. This is the rotating mirror and this one is the fixed mirror. So this distance is given here is 16 meter. Okay, and this is represented by R. So here R is equal to 16 meter. Now then the other line, the distance between the lens and the rotating mirror. So this is lens and this is rotating mirror. So this is the distance that this is 6 meter, and this is represented by B, and this is equal to 6 meter. Now talking about the third one, the distance between the source and the lens. So if in the diagram this is the source, so source and the lens distance is given here is 2 meters. So this is represented by A, which is equal to 2 meter. Now a few more things is given, that the mirror is rotating with a speed of 356 revolution per second. So here omega is given, and omega is 356 revolution per second, and if you convert this into radian, so this will be 2 pi into 356 radian per second. So this is the value of omega, and finally the shift S is 0.7 mm, and that will be equal to 7 into 10 raised to the power minus 4 meter. So now we have the value of all the variables. We have B, we have A, we have R, we have S, and we have omega. So now we will put all those values into this equation. So from this, C will be equal to, we have 4 into R square. So R is 16 and it is the square of 16. Then in the formula is omega, and omega is, we have 2 pi into 350, 2 pi into 356. So this is the value of omega. It is 356, and rest is A is given here is 2, so it is multiplied by 2 and divided by shift. Shift is 7 into 10 raised to the power minus 4 meter, so it is the shift value. And R plus, in the formula R plus B, so R is 16 and BV is 6, so it is 16 plus 6, and right here A is given as 2, we wrote A here, so it is 2. Now by doing this and calculating, when he calculated the value of C here, and he got the value of C is nearly equal to 2.975 into 10 raised to the power 8 meter per second. So this is the final answer that Foucault has been calculated by his formula, by using this formula. So this is the final value of this question. This is about this question. Thank you for watching.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.